and can waste a lot of disk space. Git branches are super fast and cheap because a branch in Git is just a pointer to a commit. So the master branch is just a pointer to the last commit in the main line of work. As we make new commits, Git moves this pointer forward automatically. So it knows what is the latest code in the main line of work. That is the snapshot stored in this commit. When we create a new branch, Git creates a new pointer that can be moved around. This pointer is just a tiny file that contains a 40-byte commit ID. That's why creating a branch in Git is blazingly fast. Now, when we switch to this branch and make new commits, Git moves this pointer forward. The master pointer stays where it is, so Git knows the latest code in each branch. When we switch back to master, Git takes the snapshot from the commit that master points to and resets our working directory to that snapshot. So we always have a single working directory. Now, how does Git know which branch we're currently working on? Using a special pointer called head. This pointer is also another tiny file that contains the name of a branch, like master. When we switch to a different branch, Git moves the head pointer around. So it updates the tiny file and writes the name of the target branch. This is how it can track what branch we're currently working on. Throughout this section, you're going to learn everything you need to know to work with branches. In this section, we're going to work with the same repository that I gave you in the previous section. If you missed that section, you can download this repository right below this video. So extract the zip file somewhere on your machine. When you're ready, watch the next lesson. Let's say we just got a bug report. Now to fix this bug, first we should create a new branch called bugfix. So we type git branch bugfix. Now to see the list of branches, we type git branch. So currently we have two branches, bugfix and master. There is an asterisk before master, which means we're currently on the master branch. You can also see that over here. As I told you earlier in the course, this is coming from ZSH or Z Shell with Git plugin. So if you're on Mac, to see something like this, you should install ZSH with Git plugin. If you're on Windows, you should install PoshGit. This is really helpful because here we can clearly see what is the current branch. One of the issues that a lot of people face is they accidentally commit their code to the wrong branch. So we're currently on the master branch. There's another way to know the current branch. We can type git status on branch master. Now, to fix this imaginary bug, first we have to change the current branch to bugfix. There are two ways to do this. In the past, we used the checkout command, but this command had multiple applications. A lot of people found it confusing. So these days we have a new command for switching branches. So git switch bugfix. Now we are on the bugfix branch, beautiful. But before going forward, I want to rename this branch. It's not clear what bug we're trying to fix here. And also in the future, it's very likely that we're going to have tens or hundreds of other bugs to fix. So it's better to use a more specific name. To rename this branch, we can type git branch -m. We type the old name and then the new name. We can use a convention like bugfix /signup-form, assuming that this bug is in our signup form. Now, if you don't like a /, you can use a hyphen here. That's a matter of personal preference. Okay, now you can see our branch is renamed, beautiful. So to make some changes, let's open audience.txt in VS Code or your favorite code editor. All right, here I'm going to make a few changes. First, I'm going to rename audience to who this course is for. Then I'm going to add a border. And finally, I'm going to remove this line. So we have three kinds of changes here: addition, modification, and deletion, okay? Obviously, these changes have nothing to do with fixing a bug on a sign-up form. But here we're not working on an application, so don't worry about the differences. I'm just teaching you how to use various tools in Git. The name of our branches, the changes we make, and the commit messages don't matter. Now save the changes. Back in the terminal, our working directory is dirty, as we can see from the yellow marker. So let's run status. We can clearly see that we have modified this file and this file is not staged. So let's add it to the staging area and then commit it. We can say fix the bug that prevented the users from signing up. Good. Now let's look at our log. So git log, one line. See what's going on here. On the top, we have head pointing to the bugfix branch. That means we're currently on the bugfix branch. And here's the latest commit in the bugfix branch. Now below that, we can see our master branch, which is just a pointer to a commit. So as you can see, our master branch is one commit behind the bug fix branch. At some point in the future, we're going to merge the bug fix branch with the master branch to bring the master branch up. But don't worry about it now. Let's just focus on managing branches. So in audience.txt, we made a few changes, and these changes are only visible in the bug fix branch. So if we switch back to the master branch and open audience.txt, we see the old version of this file. So branches allow us to work on different tasks in isolation. The code we have in these branches are isolated. At some point, we'll merge them to bring them together. Now, while we're on the master branch, if we look at our log, on the top, we can see head is pointing to the master branch, but we don't see the bug fix branch because bug fix is ahead of the master branch. So its commits are not listed here by default. To view the commits across all branches, we use the all option. Now, even though we are on the master branch, we can see the commits in other branches. In this case, the bug fix branch. Now, at some point in the future, when we are done with the bug fix branch, when we merge it into the master branch, we need to delete it. So we type git branch -d bugfix /signup-for. Now here we get an error saying the branch bugfix is not fully merged. We are saying this error because we have some changes in the bugfix branch that are not merged with the master branch. So by default, Git prevents us from accidentally deleting this branch unless we merge it first. But if you're pretty sure that we don't want the changes in this branch, we can force the deletion by using a capital D. So we say git branch -D. Now in this video, I'm not going to delete this branch because later in this section, we're going to merge the changes in this branch with master. As we commit to our branches, we need to know how they're diverging from master. So in this video, I'm going to show you a couple of different ways to compare branches. So currently we are on master. At some point in the future, we're going to merge the bugfix branch into master. But before doing so, we want to know what commits are coming in master. So we type git log master : bugfix /signup-for. So this means show me all the commits that are in bugfix branch and are not in master. Currently, we have only a single commit. If we had more commits, all of them would be listed here. And just like before, we can use the one-line option to make the output more concise. Now, what if you want to see the actual changes and not the list of commits? Well, what tool do we use for seeing the changes? Diff. So git diff, we're going to compare master with the bugfix branch. So we type master : bugfix /signup-for. So now we know that once we merge the bugfix branch into master, in audience.txt, we're going to have these changes. So these two lines are going to get removed and replaced with these two lines. Now there's a shorter way to write this command. Because we're currently on master, we don't have to type master ... here. So we can type git diff bugfix /signup-for. So this shows the differences between this branch and the current branch, which is master. Now, sometimes we don't want to see the changes in terms of the code. We just want to know what files are going to be affected. In those cases, we can use one of the options we talked about in the previous section: name only or name status. So once we merge the bugfix branch into master, audience.txt is going to be modified. So as I told you before, when we switch branches, Git resets our working directory to the snapshot stored in the last commit of the target branch. Now, if you have local changes in our working directory that we haven't committed yet, these changes could get lost. In these situations, Git doesn't allow us to switch branches. Let me show you how this happens and what you should do about it. So in the previous lesson, we made some changes in audience.txt in our bugfix branch. Like currently we're on the master branch. So let's open audience.txt and make some other kind of changes. So here I'm going to add an asterisk just to indicate a change. Save, back in the terminal. Our working directory is dirty because we have some local changes we haven't committed yet. So let's say we're in the middle of something, and then we have to quickly switch to the bugfix branch. If we type git switch bugfix /signup-for, we get an error saying your local changes to the following files would be overwritten by checkout. Please commit your changes or stash them before you switch branches. Now, in this case, I don't want to commit the changes because I'm not done yet. So in situations like this, we should stash our changes. Stashing something means storing it in a safe place. So we're going to store this somewhere in our Git repository, but this is not going to be part of our history. Let me show you how this works. So we type git stash push -m and give it a message. With this message, we can tell what these changes are all about. Let's say new tax rules. So I was working on the new tax rules, and then I had to quickly switch to the bug fix branch, right? So saved working directory and index state on master, and here's the message. Now, as you can see over here, we have one stash. Just remember, by default, new untracked files are not included in your stash. So as an example, if I create a new file here, let's echo hello to new file.txt. Now let's run a short status. So we have a new file. If I stash the changes, this new untracked file is not going to be included in the stash by default. To include it, we have to use the all option. So we say git stash push -all, or just -a, then -m, or we can combine these two options into a single option. Now we give it a message, my new stash. Of course, the message should be something more meaningful. So now we have two stashes. You can see that over here. To view our stashes, we type git stash list. So we have two stashes. Each stash has a unique identifier, stash at, in curly braces, we have an index. Now, as you can see, our working directory is clean. So we can switch to the bug fix branch, no problem. We can do our work here. When we're done, we get back to the master. At this point, we want to apply the changes from one of our stashes to our working directory. But before doing so, we may want to look at those changes to see what lines of code have been modified. So we type git stash show, and here we type the name of the stash, like stash at curly braces 1. Now we can make this shorter by using just the sequence number. Now we know that in stash number 1, one file has been changed, that is audience.txt. Here we have two changes, one insertion and one deletion. So we can go ahead and apply this stash on our working directory. So git stash apply 1. The changes are applied to our working directory, beautiful. Now when we're done with this stash, we want to remove it to clean things up. So we can type git stash drop 1. That stash is removed. Let's look at our stash list one more time. We have one more stash. Let's say we don't need this anymore. So we can type git stash drop 0, or to remove all stashes, we can type git stash clear. All our stashes are gone. Merging is all about bringing changes from one branch to another. In Git, we have two types of merges, fast-forward merges and three-way merges. Let's study each of these merges using a real example. So here's the master branch with 3 commits. We create a new branch called bugfix. As I told you before, in Git, a branch is just a pointer to a commit. So in this case, both master and bugfix pointers are pointing to the same commit. Now we switch to the bugfix branch and make a couple of commits. We're done here. Now we need to bring the changes back to master. Now, because these branches have not diverged and there is a direct linear path from bugfix to master, all Git has to do to merge the changes is to bring the master pointer forward. This is what we call a fast-forward merge. Now, if you're confused about this, let me give you a simple example. So forget about Git for a second. Imagine we have a directory called master, and the code in this directory is at version 1.0. We take a copy of this directory and call it bugfix. At this point in time, the code in these directories are identical, right? Now we start making some changes to the bugfix directory. So we get to version 1.2. We're done here. We want to bring the changes back to master. How do we do this? Well, one way is to copy all the files from bugfix into master. But this is not the best way to solve this problem. What if you have thousands of files? This copy operation might take a few seconds. There is a better way. Since we don't have any additional changes in master, and essentially what we have in master is the first version of bugfix, we can simply rename bugfix to master. So from this point forward, we can say this is our new master directory. The idea of a fast-forward merge in Git is very similar. So if two branches have not diverged and there is a direct linear path from the target branch to the source branch, Git runs a fast-forward merge. It simply brings the pointer of the source branch forward. Now that we're done with the bugfix branch, we can simply remove it, which removes the pointer. Now let's look at an example of a three-way merge. In this example, our bug fix branch is 2 commits ahead of master. But before we merge it with master, let's go back to master and add an additional commit. Now our branches are diverged. So we have some changes in master that don't exist in the bug fix branch. So if you run a merge, Git cannot move the master pointer forward and have it point to the same commit as bug fix, because otherwise we'll lose the latest commit in the master branch. So when we run a merge, Git creates a new commit that combines the changes from these 2 branches. Now, the reason this is called a 3-way merge is because this new commit is based on 3 different commits. The common ancestor of our branches, which includes the before code, and the tips of our branches, which contains the after code. So Git looks at 3 different snapshots, the before snapshot and after snapshots. Based on these, it will figure out how we should combine the changes. So it creates this new commit, which is called a merge commit. So to recap, in Git, we have 2 types of merges. Fast-forward merges, which happen if branches have not diverged, and 3-way merges, which happen if branches have diverged. Over the next few videos, we're going to see examples of these merges in action. Let's see a real example of a fast-forward merge. So first, let's look at our log. And by the way, when you're using branches, it's a good idea to always include the graph option. At this point in time, you're not going to see any differences, but as we go forward, you will see that the graph option will give us a better representation of our branches and how they diverge. Of course, I know this command is very long and you're not supposed to write this every single time. That's why we use aliases. But as I told you before, in this course, I'm not going to use aliases because I want anyone to be able to follow this course. So let's look at our log. As you can see, our bug fix branch is 1 commit ahead of master. Also, as you can see here, we have a linear path. So if you start from bug fix, we can get to master. So master has not diverged from bug fix. That means when we run a merge, Git will fast forward master. Let me show you. So to bring the changes from the bug fix branch into master, first we should be on master. Then we run git merge bugfix / signup form. I don't know why my autocomplete is not working on this machine. So let's run. Look, we have a fast forward merge, and this file is the only file that was changed with 5 changes. Now, let's look at our history one more time. So now both these branches are pointing to the same commit, which is the latest commit over here. And we have a linear history. Now, it is possible to disable a fast forward merge, and this has a number of benefits. So let's create a new bug fix branch, make a new commit to it, and then merge it with master using a no fast forward option. So earlier I told you that to create a branch, we type git branch and then type the branch name. But after this, we have to switch to that branch. So there are 2 steps we have to follow. Now, let me show you a shortcut. We can type git switch -c for create. And with this, we can create and switch to a branch in 1 step. So I'm going to call this branch bugfix / login form. Now we are on this new branch. So let's open our table of content file and add an asterisk here. Save. Back to the terminal. Let's commit the changes. For the commit message, I'm going to say update table of content.txt. Okay. Now let's look at our history. So git log 19 all graph. Take a look. So our new branch is 1 commit ahead of master. And by the way, we probably don't need this branch anymore, so we can drop it. But that aside, let's merge our new branch into master using a no fast forward option. So first we have to switch to master, git switch master. Now we run git merge. Now here we have to use the no fast forward option. So no fast forward. Then we type the branch name. So bugfix / login form. So with this, we're telling Git, hey, even if fast forward is possible, don't do it. Create a merge commit that combines all the changes in this target branch and bring them into master. Take a look. So our default editor is opened. Here we have to type a commit message because we're going to have a merge commit, a new commit in the master branch. By default, Git suggests this message, merge branch bugfix / login form into master. Most of the time, the default message is totally fine. So we can close this. Now back to the terminal. We no longer have a fast forward merge. So let's look at our history one more time using the graph option. Let's see what's going on here. So here's our new bugfix branch, which originated from this commit over here. So before we merged this into master, master was pointing to this commit, and this is when we created our new bug fix branch. In this branch, we added a new commit, which was for updating our table of content file. Then we merged this branch into master. So see the graph? This is coming from the graph option. If we don't use the graph option, we'll see everything in a linear way. So our master is pointing to this commit, which is our merge commit, and here's the commit message that you just saw. Now, what is the benefit of this approach? Why should we disable fast-forward merges? Well, this is one of those areas that gets a bit controversial. In the Git community, we have two groups of people. Some people hate merge commits, and they argue that these merge commits pollute the history. They make it harder to read and understand what's going on, especially as we have more and more branches. These people prefer a linear history. On the other hand, we have another group of people who argue that these merge commits are a true reflection of history, a true reflection of what actually happened when we merged our branches and how they were merged. In my opinion, both these arguments are valid. It's definitely easier to read a linear history, but you should also remember that a linear history is not your true history. It's a lie. Now, that aside, these merge commits have another benefit. They make it easier for us to undo a feature. Let's talk about it using a real example. So here we have two branches, master and feature, and our branches have not diverged. So there is a direct linear path from feature to master, right? So here we can use a fast forward merge. But let's see what happens if we don't use a fast forward merge. We're going to have a merge commit that combines all the changes in the feature branch. So if you have F1 and F2 in the feature branch, this new merge commit combines all the changes in F1 and F2. Now, let's say we work on this feature, and then next day we are told to remove this feature from the code base. We can easily revert the last commit in the master branch. We'll talk about reverting commits in the future when we talk about rewriting history. But basically, by reverting a commit, we create a new commit that is the opposite of that commit. So essentially, it undoes everything that has happened in another commit. So if we use a merge commit, there is a single commit that we have to revert. In contrast, if we use the fast forward option, our master pointer is going to move over here. And now if you want to take out this feature from the code base, we have more commits that we have to revert, and this can get a bit more complex. So once again, both these arguments are valid. It really depends on your team culture and the kind of project you're working on. So I leave it up to you to decide what approach works best for you. Now, where you work, you might have a policy in your company saying no fast forward merges. In that case, you don't want to type git merge no fast forward every time. What if you forget? So let me show you a better way. We can disable fast forward merges for a particular repository or for all of our repositories. So we type git config fast forward no. This will disable fast forward only in the current repository. But if you want this to apply to all of your repositories, of course, you should use the global option here. Now let's look at an example of a three-way merge. First, let's look at our history. So this is where we are. Our master branch is at this commit, which is a merge commit. Now I'm going to create a new branch for implementing a new feature. So git switch -c for create. We're going to call that branch feature/change password. So now we have this new branch. Let's look at our history one more time. So at this point, both these pointers, our change password pointer and master pointer, are pointing to the same commit. Now, what we want to explore in this lesson is how two branches can diverge. So we're currently on the change password branch. Let's make a commit here. I'm going to echo hello to, let's say, change-password.txt. Now we're going to stage the changes and commit them and say, build the change password form. Now, let's look at our history again. So as you can see, our change password branch is one commit ahead of the master branch, right? But our branches have not diverged yet because there is a direct linear path from the change password branch to master. So to make these branches diverge, I'm going to go back to master and make a new commit. So git switch master. Let's open objectives.txt and make a small change here. It doesn't really matter. Now, back in the terminal, let's run git add and then commit and say update objectives.txt. So now both the master and change password branches have a new commit. Take a look. So git log Okay, here's master and here's the change password branch. As you can see, our branches have diverged. This is the commit where we started the change password branch. We added a new commit in this branch and got back to master and added a new commit to master. Now we do not have a direct linear path from change password to master. So if we start from here, we cannot go to master. So when we try to merge the changes, Git is going to run a three-way merge. It's going to look at the tips of these branches, which is this commit and this commit over here. It's going to compare these with their common ancestor, which is in this case, this commit over here. Based on their differences, it's going to figure out how to merge or combine the changes into a new merge commit. So here on the master branch, we type git merge feature/change password. Once again, we have a default message for the merge commit. We can accept it as is or change it if we need to. So let's close this window. Now back in the terminal. As you can see, we don't have a fast forward merge. Now let's look at our history one more time. So here's the result of the merge. Our change password branch is pointing at this commit. Our master was here. Now we combine these two into a new merge commit over here. So typically when we're done working on a branch, we should merge it into master and then delete it. Now, sometimes we may forget to delete a merged branch, so that branch will be sitting there, and after a while, we may forget that we already merged that branch into master. So let me show you how to view the list of merged and unmerged branches. So currently we're on the master branch. To view the list of branches that we have merged into the current branch, which is master, we type git branch -- merged. So all these branches have been merged into master, and we can say that it's safe to delete them if you're done working on these branches. So as a best practice, whenever you're done working on a branch, you should delete it. Otherwise, that branch or that pointer will be sitting there and creating confusion in the future. So here we can say git branch -d bugfix/login for. Here in the branch command, we also have another option called no merged. This returns the list of branches that have not been merged into the current branch. So currently all our branches have been merged, and that's why we don't see anything in the output. So you have seen examples of merging branches. Now, in the real world, quite often when we merge branches, we run into conflicts. Conflicts happen when the same line of code has been changed in different ways in two branches, or if a given file is changed in one branch, but is deleted in another branch. Another scenario is when the same file is added twice in two different branches, but the content of this file is different. In these cases, Git cannot figure out how to merge the changes. So it will stop the merge process, and that's when we need to jump in and tell Git how we want to proceed. Let me show you a real example. So here on the master, let's create a new branch called bugfix/change password. Now let's open change password.txt. Here on the second line, let's say change in the bugfix branch. Save the changes. Back in the terminal, let's add this to the staging area and commit it. We can say update change password.txt. Of course, this is not a good commit message because it's tied to a particular file, but it's fine for this demo, so let's move on. All right, so we changed this file in this branch. Now let's switch to the master branch and update the same file in a different way. So let's open it. Here on the second line, I'm going to say change in the master branch. All right, now back in the terminal, let's add this to the staging area and commit it with the same commit message. So now this file is changed in different ways across these two branches. So when we run git merge bugfix/change password, we get a conflict. We get a merge conflict in change password.txt. So Git stopped the merge process, and now we have to jump in and manually combine the changes. Also, as you can see over here, we are in the middle of a merge process. So let's run git status. Look under unmerged paths. This is where we can find the conflicted files. So both our branches have modified change password.txt. Now, this is a very simplified example. In a real-world scenario, you might have more than 10 files listed here. Basically, the more your branches diverge, the more conflicts you're going to have. We're going to talk about this later in this section. For now, let's just see what you need to do when there is a conflict. So we're going to open changepassword.txt. Look what's going on here. The first time I saw this, I was like, what the hell is going on here? But this is very simple. Here we have markers that represent the changes in the current branch and in the other branch. So over here, we have these markers. In front of that, we have head, which points to the current branch. In this branch, which is the master branch, we have introduced this line. Now, after this, we have this divider. And below the divider, we have the changes in the other branch. So that is this line over here. And after this, we have the marker for the other branch, bugfix/changepassword. Now, in a real situation, you might have multiple conflicts in the same file. So for different chunks of code, you're going to see these markers. Now, let's see what we can do here. Here in VS Code, we have a few options. We can accept the current change. If we click this, all those markers are gone, and we are left with the change in the master branch. Let's undo this. Alternatively, we can accept the incoming change. So once again, all the markers are gone, and now we have the change in the other branch. Let's undo this. Another option is to accept both changes. Let's undo this again. So here are the options in VS Code. We also have third-party merge tools for handling conflicts. We'll talk about them in the next lesson. But before we get there, let me show you a different way of resolving conflicts. We can manually edit this file by hand and remove these markers. So I'm going to remove the head marker. Okay. I'm also going to remove the divider and the second marker. So here we have changes in both these branches. We can reorder them, so we can put this one first. So this is how we are manually merging the changes. Now just remember that ideally, you should not introduce new code here. So here we should not add a new line of code because this line of code was not introduced in any of these branches. It's a new line that we're adding in a merge commit. If we do this, this merge commit is referred to as an evil commit because it's introducing changes that didn't exist in any of these branches. The whole point of a merge commit is to combine changes across two branches, right? So as much as possible, try not to introduce new changes here. But I know in real world situations, sometimes this is not avoidable. There are cases where you need to manually edit the changes and introduce something new. Now let's delete this line, save the changes. Back in the terminal, we have to add this file to the staging area. Why? Because this is what we're proposing for the next commit, right? So now let's run git status. We no longer have unmerged paths, which means we no longer have conflicts. So we have modified this file, changepassword.txt. Now we run git commit. We can leave out the message option and accept the default message, merge branch bugfix into master. So let's close this. Back in the terminal, we're done with the merge. Quite frankly, VS Code is not the best tool for resolving conflicts, at least not at the time of recording this lesson. So let's look at some other tools for resolving conflicts. There's so many tools out there. The most popular ones are Kdiff and P4Merge, which are cross-platform, and WinMerge, which is for Windows only. Now, if you use Gitkraken or a powerful IDE like IntelliJ, you don't need any of these external merge tools. But I still encourage you to watch this lesson to the end because the skills you're going to learn will transfer to other tools. In this lesson, we're going to use P4Merge for resolving conflicts. So open up your browser and search for P4Merge. Over here on perforce.com, you can download the latest version. Let's go with this. Here you have to select your operating system. I'm going to go with Mac and download the latest version. We don't have to register, so let's skip registration. Good. All right, so we get a DMG file on Mac. If you're on Windows, you'll get a setup wizard. So let's drag and drop P4Merge onto applications. It's saying that I already have this, so I'm going to replace it with the latest version. Good. Now here in the terminal, we have to configure P4Merge as our default merge tool. So we say git config -- global merge.tool. We give it a name, P4Merge. Next, we need to tell Git where to find P4Merge. So once again, git config -- global merge tool dot P4Merge. That is the name we assigned over here. Dot path. Here in double quotes, we should add the full path to P4Merge. If you're on Windows, your path is going to be like // program files backslash p4merge, backslash whatever, depending on where you have installed this. On Mac, the path is going to be slash applications slash p4merge.app slash contents slash macOS slash p4merge. Make sure to spell it properly, exactly as what you see here. All the uppercase and lowercase letters are different because macOS is a case-sensitive operating system. Okay, so we have configured our default merge tool. Now we need a merge conflict. To save time, I'm not going to recreate another merge conflict. I'm going to simulate the previous conflict. So we're on master, and we want to merge this with our bug fix branch. So git merge bugfix / change password. All right, we got a merge conflict exactly like before. Now in the previous lesson, we opened change password in VS Code to edit the conflict here. Now this time, we're going to use our external merge tool. So we run git merge tool. All right, here we have 3 copies of our change password file. On the left side, we have change password _remote. This is the version we have in our remote or target branch, which is our bug fix branch. In the middle, we have change password _base. This is the base copy, the base version. So here's the version of this file before our branches diverged. And on the right side, we have change password _local. So this represents the changes we have in the current branch, which is the master branch. Now, the beauty of this tool is that here we can visually see the conflicting changes. So unlike VS Code where we had those ugly git markers, here we can easily see that on the second line, we have a conflicting change. Now down below, we can see how these changes are going to get combined. So by default, p4merge is bringing changes from both branches, but we can easily change this. So on the right side, we have 2 icons, purple and green. Purple represents the changes on the left side. So look at the legend over here. We have a purple icon that represents the left side, the changes in the remote branch. The green icon represents the changes in the local branch, which is master. So if we click on the purple icon, now we only have the changes in the local branch. Now, while green is selected, we can select the other branch by holding down Shift and clicking. So now we have the changes in both these branches. This is the idea of p4merge or visual merge tools. Pretty much all merge tools out there work in a similar fashion. Now, if you have multiple conflicts in the same file, we can browse through them using these buttons on the toolbar. So we resolve the conflicts. When we are done, just like before, we need to save the changes, then go back to the terminal and commit them. So we should close p4merge. Now back in the terminal, let's stage the changes and make a commit. I'm going to accept the default message. So let's close the window. And we successfully merged our branches. So you learned that when doing a merge, we may run into one or more conflicts. Now, what if we're not quite ready to handle these conflicts? Perhaps we have several conflicts and we are in the middle of something, so we don't have enough time to spend on resolving these conflicts. In situations like this, we can easily go back to the state before we started the merge. So here we have a merge conflict. To abort the merge, we simply type git merge -- abort. Now we're back to the state before we started the merge. So if we resolve some conflicts and stage the changes, those resolutions are gone. We're back to a clean state before we started the merge. Sometimes we do a merge and then find out that our code doesn't get compiled or our application doesn't work. That happens if we screw the merge, if we don't combine the changes properly. In situations like this, we need to undo the merge and then remerge. So let's have a quick look at our history. On the top, we have a merge commit. Let's say this is a faulty merge, so we want to undo it. Here we have 2 options. One option is to remove this commit as if it was never there. Now you have to be a bit careful with this solution because as part of removing this commit, we are rewriting history. Rewriting history is totally fine if this history is local in our repository. But if we have shared our commits with other team members, if we have pushed our commits to a remote repository, then we should not rewrite our history. We'll talk about this in more detail in the future. In situations like this, instead of removing this commit, we should revert it, which means we're going to create a new commit that will cancel all the changes in this commit. In this lesson, we're going to look at both these solutions. First, let's see how we can remove the last commit. So here's a picture of our history. Both the head and master pointers are pointing to the last commit, which is a merge commit. Now we're going to use the reset command to move both these pointers and have them point to the last commit on the master branch before we started the merge. Now look at our merge commit. We don't have any other commits or any pointers pointing to this commit. So from Git's point of view, this commit is garbage. Once in a while, Git looks for commits like this and automatically removes them from our repository. So here in the terminal, we type git reset --hard. I will explain what this means in a second. We want to reset head to head ~1. That is one commit before the last commit. Now, what is this hard option here? When resetting the head pointer, we have three options: soft, mixed, and hard. What is the difference? Well, here we have our working directory, our staging area, and the last snapshot. When we reset the head using the soft option, Git is going to have the head pointer point to a different snapshot, but our staging area and working directory are not affected. If we use the mixed option, which is the default option, so we don't have to specify it, Git is going to get that new snapshot and put it in the staging area as well. So if you have local changes in our working directory, they are not affected. They're going to stay there. If we use the hard option, Git is going to take that new snapshot and put it in our working directory as well. So all our environments are going to look identical. This is the state that we were in before we started the merge. All our working environments were identical. So back to the terminal, we're going to reset head to the last commit on the master branch before we started the merge. That is this commit over here, update change password. But before doing so, I want to take a copy of the last commit ID, that is our merge commit. Let's copy this and put it somewhere. Now we type git reset --hard head ~1 to go one step back. Good. Now head is pointing to this commit over here, update change password. Let's look at our log. Look, the merge commit is no longer in our history, but it's still in our repository, so we can recover it. Let me show you. So we type git reset --hard. Now we're going to paste the ID of our merge commit that we copied earlier. Okay, let's go with that. Now head is pointing to this commit over here. That is our merge commit. So let's look at our history. So here we have our merge commit. Before that, we have the last commit on the bug fix branch, and here's the last commit on the master branch. So you learn how to undo a merge commit. But as I told you before, you should do this only if you haven't shared your history with others. We'll talk about that in the future. At this stage, all these commits are local in our repository. We haven't shared our history with others. We haven't pushed our commits. So undoing is totally fine. But if you have shared our history, instead of undoing, we have to revert the last commit. So we type git revert head. We want to revert the last commit, which is our merge commit. Take a look. We got this error saying this commit is a merge, but no -m option was given. What's going on here? Here's our merge commit. As you can see, a merge commit has two parents. One parent on the master branch, the other on the feature branch. So to revert this merge commit, we have to tell Git how we want to revert the changes. In this case, we want to revert to this commit over here, the last commit on the master branch before we started the merge. This commit over here is the first parent of our merge commit. Because our merge commit is on the master branch, so the first parent should also be on the master branch. So we type git revert -m1, which means the first parent, and then we specify the target commit. That is the last commit. Okay, git open our default editor. So here we have a default commit message saying revert, and here's the commit we are reverting. Down below, we have more details. It's saying this reverts this commit over here, revising changes made to this commit over here. We're going to accept the default message, so close. All right, we're done. Let's look at our history. So here's our merge commit. Right after that, we have a new commit, which is reverting our merge commit. Here we have a bug fix branch with two commits, B1 and B2. Let's say we're done here, so we do a merge. Now these commits, B1 and B2, are part of the history of master, right? But what if these commits are not good quality commits? Maybe they're too fine-grained, or they don't represent a single logical change set. Maybe we have mixed different things in each commit, so these commits are not good quality commits. Perhaps we added these commits as checkpoints along the way. So we don't really care about the history of the bug fix branch. So we don't want these commits to pollute the history of our master branch. In situations like this, we have a better solution called squash merging. So let's undo the merge. We're going to create a new commit that combines all the changes in the bug fix branch. So we have a single logical change set that represents all the changes for fixing this bug. Now we can apply this commit on top of master. This is what we call squash merging. Now what you need to pay attention to here is that this new commit is not a merge commit because it doesn't have two parents. It doesn't have a reference to B2. It's just a regular commit that we have added on top of master. Now we're done with the bug fix branch, so we can delete it, and we are left with a simple, clean, and linear history. This is the benefit of squash merging, but it doesn't mean you should use this technique all the time. You should use it with small, short-lived branches with bad history, like bug fixes or features that you can implement in a few hours or in a day. Now let's see squash merging in action. So let's start off by creating a new branch called bugfix/photo upload. In this branch, we're going to make two commits, and in each commit, I'm going to update one file. So let's echo bugfix to audience.txt. Now we're going to commit. Using -a option, we're going to stage and commit all the changes in one step. We talked about this at the beginning of the course, remember? So let's give it a message. Update audience.txt. Now let's make a second commit. So echo bugfix to table of content.txt. Once again, we're going to commit all the changes in one step and say update table of content.txt. So here we have two commits. Let's look at our history. So git log, one line, all graph. So our bugfix branch is two commits ahead of master, the first commit and the second commit. Now in this case, we can do a fast forward merge, but let's say the master branch has evolved and we're not going to do a fast forward merge. So instead of doing a regular merge, which adds a merge commit, we're going to do a squash merge. So first we switch to the master branch, git switch master. Now in the past, we typed git merge bugfix/photo upload. Now here we're going to add an option called --squash. Let's see what happens. Git created a new commit called a squash commit, which combines the changes across these two files. But we don't have a commit yet. All these changes are in our staging area. Let me show you. So git status -s. Look, both these files are modified and they're staged. So now we have to make a commit. So git commit -m. Here we type a meaningful message that represents all the changes in our bugfix branch. So we say fix the bug on the photo upload page. All right, let's go. Let's bring up the history. So here on master, we have a new commit that combines all the changes for fixing this bug. So once we remove the bugfix branch, we're going to end up with a simple, clean, linear history. But before doing this, let me show you something. I'm currently on master. Earlier, I showed you how to view the merged branches. We type git branch --merged. Look, our new branch, bugfix/photo upload, is not in this list because technically we don't have a merge commit that connects these two branches. So when doing a squash merge, it's super important to remove your target branch. Otherwise, that branch will be sitting there and may create confusion in the future. For example, you might run git branch --no merged and think you haven't merged this branch into master. This is confusing. So we type git branch -d to remove bugfix/photo upload. Now we're going to get an error. Can you tell why? Take a look. The branch photo upload is not fully merged because once again, Git does not see this as a real merge. So here we have to enforce the deletion using a capital D. Okay, our branch is gone. Let's look at our history one more time. So we have a simple linear history. We have a single commit that combines all the changes for fixing the bug on the photo upload page. One last thing before we finish this lesson. When applying a squash merge on top of master, we might end up with conflicts. The process for resolving conflicts is exactly like before. So we bring up our merge tool, resolve the conflicts, and then make a commit. Let's talk about another technique for bringing changes from one branch into another. So here we have a feature branch with two commits. When we're done, we can do a merge, but we'll end up with non-linear history. Now, our history here is not too bad. It's not really complicated. But as we have more branches and we're working on more complex scenarios, our history might get really hard to read. So here we can use a different technique that will result in linear history. So we go back to the state before we do a merge. Look at the base of our feature branch. This is where we started the feature branch, right? Now, using the rebase command, we can change the base of our feature branch. So we can base it on the latest commit on master. What's the point of this? Well, look at the shape of our history. We have a direct linear path from feature to master. So if you want to merge the feature branch into master, we can do a fast forward merge. And now we have linear history. This is called rebasing. Now, while this sounds like a great idea, you need to be cautious with rebasing because rebasing rewrites history. And that means you should use rebasing only for branches or commits that are local in your repository. If you have shared these commits with other people in your team, if you have pushed your changes, you should not use rebasing. Otherwise, you're going to make a big mess. Let me explain why rebasing rewrites history. So here's the state before rebasing. When we rebase the feature branch, Git is not going to change the base or the parent of F1 because commits in Git are immutable. They cannot be changed. So Git is going to look at these commits. It's going to create new commits that look like F1 and F2 and apply them on top of master. Then it's going to move the feature pointer over here. Now look at F2. We don't have any branches or any other commits pointing to it. So at some point in the future, Git is going to remove this commit. So we are essentially rewriting history. These two commits that we have here, they're not the same commit as before. So if you have shared F1 and F2 with others, and other people have created new commits on top of F2, now after rebasing, their history is going to get screwed. So let's create a new feature branch called shopping cart. Git switch-c feature/shopping cart. Now let's make a commit in this branch. So I'm going to echo hello to cart.txt. The change doesn't really matter. Now let's add this to the staging area and then make a commit. Here we say add cart.txt. Now let's look at our history. So our shopping cart branch is one commit ahead of master, right? So if we do a merge, Git will do a fast forward merge. Now let's go back to the master branch and make a new commit. With this, our branches are going to diverge. So we should either do a three-way merge or rebase. So let's go back to master. Here we're going to echo hello to table of content.txt. Now we're going to commit the changes and say update table of content. Good. Let's pull up the history one more time. Look, our branches have diverged. This is the base of these branches. This is where we created the shopping cart branch. Now in our shopping cart branch, we have this commit over here. And in master, we have another commit. So our branches have diverged. Now the number of commits doesn't matter. We could have tens of commits in each of these branches. What we want to do now is rebase the shopping cart branch. So we want to change its base from this commit over here to the last commit on master. So first we have to switch to our target branch. Git switch feature/shopping cart. Now we're going to run git rebase master. We're telling Git to change the base of this branch to the last commit on master. Beautiful. In this case, rebasing was done successfully. That is not the case in the real world. Most of the time, when you rebase, you end up with conflicts. We'll talk about it in a moment. But first, let's pull up our history one more time. So git log. All right, look, our branches have no longer diverged. We have a direct linear path from our feature branch onto master. So now if we decide to do a merge, Git will do a fast forward merge to bring the master pointer upward. So let's switch to master. We run git merge feature/shopping cart. Look, we have a fast forward merge. Now let's pull up the history one more time. So both our branches are pointing to the same commit over here, and we have a simple, clean, linear history. Now, what if there's a conflict? Well, let's have a look. So currently we're on master. Let's echo ocean to table of content.txt. The change doesn't matter. I just want to create a conflicting change. Now, let's commit the change and say update table of content.txt. Good. Now let's switch to our feature branch and make a conflicting change. So we're going to write something else to table of content.txt. So git switch feature / shopping cart. Now we echo, let's say mountain to table of content.txt, and then make a commit. Write mountain to table of content. Now our branches have diverged and we have a conflicting change. Let's verify this. So git log. Look, our branches have diverged one more time. We have this commit in our shopping cart branch and this other commit in master. And here's the base of our feature branch. So when we try to rebase it on top of this commit, we're going to see a conflict. Take a look. So we go to our feature branch and then run git rebase master. Look, we have a conflict in this file, table of content.txt. So here we should resolve the conflict exactly like before. We're going to launch our merge tool. So we say git merge tool. So here we need to decide how we're going to combine the changes. For this demo, it doesn't really matter. I'm going to pick one of these changes. Now we save the changes and close P4 merge. So as you can see in the terminal window, we are in the middle of rebasing our shopping cart branch. So next we type git rebase -- continue to tell Git to apply the next commit on top of master. Now, if the next commit also has a conflict, again, we're going to end up in the same state. So we have to resolve the conflict and then tell Git to continue rebasing. Alternatively, we can use another option, skip. This will skip the current commit and move on to the next commit. So if we look at the conflict and we realize that we don't actually care about this commit, we can skip it. We have another option here, and that is abort. This is useful in situations where we have so many commits to apply on top of master, perhaps our branches have diverged for a long time. In that case, if we don't have enough time for resolving all these conflicts and going through a complete rebase, we can abort the rebase here. So this will take us back to the previous state before we started rebasing. One last thing before we finish this lesson. Look at this question mark over here. That means we have new untracked files. Let's verify it. So git status. Look, we have table of content.txt.origin. What is this? Well, our merge tool, in this case P4 merge, automatically created this file as a backup. So let's look at the content of this file. So this is our table of content file before we resolve the conflict. We don't want this file in our repository. So we can remove it using the rm command or git clean, assuming that we don't have other untracked files that we want to add to our repository. Now our working directory is clean. We don't have any new untracked files, but for the future, to prevent our merge tool from automatically generating these files, we can set git config -- global merge tool dot keep backup to false. Here we have a feature branch with two commits, F1 and F2. Now, let's say one of these commits, like F1, has some interesting changes we want to have in master, but we're not quite ready to merge our feature branch into master. What should we do now? This is where we use cherry picking. So we can cherry pick this particular commit and apply it on top of master. Let me show you how to do this. Here in our history, you can see that our feature branch is one commit ahead of master. Now we're going to bring this particular commit into master without merging. So I'm going to copy this commit ID. Now we're currently on master. We type git cherry -pick and then type the commit ID. Here we have a conflict in table of content.txt. So let's open up our merge tool. Now in this demo, I'm going to take the changes in the remote branch, which is our feature branch. So I'm going to select this purple icon. Good. Save the changes. Close the merge tool. We're back here. As you can see in the terminal window, we're in the middle of a cherry pick. Let's have a quick look at our staging area. So our table of content file has some changes that are in the staging area. We also have this directory here, ds_store. Don't worry about it. This is only for Mac computers. This is one of those standard directories that we need to include in our git ignore file. For now, let's not worry about it. So let's make a commit. I'm not going to specify a message. The default message that we have here is based on the commit that we were trying to cherry pick. So we can accept it or change it if necessary. Now, close. Back in the terminal. Let's look at our history one more time. So master has moved forward, and now we have this new commit that we cherry-picked from our feature branch. So you learn how to